Good day everyone. So for the problem number 3, determine the components of reaction at fixed support. Neglect the thickness of the beam. So in our figure, we have here the forces going up, which is the AY. It's going up since all the forces curves going downward. And we also have the forces, one force here going to the left, which is the AX. It's going to the left since the 400 Newton is going to the right. So the first thing we are going to solve is the summation of forces along X, which is the summation of forces along X is equal to 0. So the summation of forces along X is equal to 0. Negative x, ax, it's negative since it's going to the left. So negative ax plus the force, the magnitude of 400 Newton. 400 Newton cos angle 30 degree is equal to 0. So if we are going to put this equation in our calculator, we come up with a result of AX is equal to 346.41 Newton. So that is our summation of forces along X. AX is equal to 346.41 Newton. Now, we are going to solve now the summation of forces along Y, which is the summation of forces along Y is equal to 0. So, positive AY minus the 200 Newton times its distance is 3 meters minus the 400, it's 400 since it's going down, so minus the 400 sine 30 degrees is equal to 0. Now, if we are going to solve this using our calculator, we will get the answer of 800 Newton. So that is our answer for summation of forces along X and summation of forces along Y. The next that we are going to solve is the moment A. So the moment A, the moment A. So the moment A positive, moment A positive is equal to 0. So moment A minus the first magnitude of 200 Newton. So 200 Newton times the distance of 3 in the angle of 60 degree. So times 3 cos 60 degree plus the distance from point A to the first magnitude, which is point A to the first magnitude, it is 1 meter. So plus 1. So we're going to put plus 1. Next is the second magnitude of 200. So minus 200 times 3 cos 60. 3 cos 60 plus the distance from point A to the second magnitude, which is 1 plus 1 is equal to 2. So plus 2. Next is this one, minus 200. Minus 200 times 3 cos 60. 3 cos 60 plus the distance from point A to the third magnitude. From point A, so 1 plus 1 plus 1 is equal to 3. Next is, we have here the y component and the x component and y component in our magnitude 400 going to the right. So, negative 400 sine, that is sine 30 degree. So sine 30 degree, sine 30 degree times cos 3 cos plus the angle of 60 degree. 60 degree plus the distance of 3. 1 plus 1 plus 1 is equal to 3. Now for the component of y, and for the component of x, so negative 400, this side 30 will become cos 30 degree times 3 sine 60 degree. So if we are going to solve this using our calculator, the summation at the moment A, the answer of the moment A is equal to 3,900 Newton per meter. So that is our final answer for the moment A. So we have the three answers. The summation of forces along X is 346.41. The summation of forces along Y is 800 Newton. And our moment, the answer for our moment A is equal to 3,900 Newton meter. So do you have any questions or clarifications regarding my discussion?
So, good day everyone. So here is another example of a equilibrium of rigid bodies problem. So here is the problem. The 25 kilogram bar is the center of a mass at G. If it is supported by a smooth bag at C, a roller at A, and a cord at AB, determine the reaction at this cord. So first, let us identify or let us see what supports are there in this figure. So as you can see here, A has a roller support. So A has only vertical support. So at point G, the center of the mass, so I have the weight acting on a downward direction. So weight is equal to 25 kilogram. So it has a normal reaction because of the peg at C. So at the point C, which is perpendicular to the segment A and B. So I have the force due to its cable or cord A and B. So first we need to calculate the weight, which is 25 kilograms times 9.81 equal to 245.25 Newton. So, this chord AB is now tension TAB. So I can solve for the first. To find the support of the reaction AX, let's see first the equation equilibrium, which is the summation of moment at point A is equal to 0. So, the moment arm is the horizontal distance. So first, we need to identify the reactions here at G. So since the weight is acting downward, so it is negative. So negative 245.25. So the moment arm is a horizontal distance, which is 0.5 cos 30, because we have an angle here which is 30 degrees. So times 0.5 cosine 30 degrees. So plus moment and force NC. So NC is a force trying to rotate the counterclockwise direction. So about point A, so the moment produced by the NC force will be positive. So that's why it's plus NC. So a moment produced by the NC will be positive. So we have a positive NC. The moment arm, since NC is perpendicular to the bar AB, so 0.5 plus 0.2 is 0.7 times 0.7 is equal to 0. So, we find NC. If we calculate it in our calculator, the answer will be 151.71 Newton. And now, to solve for TAB, we have to identify the forces that act at the x direction. So, summation of forces at x is equal to 0. So, we have to identify first the forces that act in TAB. So, this is the x direction and this is for the y direction. So, TAB cosine 15. Cosine 15 is it because we as the figure shows, we have two angles, which is 30 degrees and 50 degrees. So we are now going to use the 50 degrees. So that's why we come up with TAB cos 15. So for the vertical direction, we have TAB sin 15. So for TAB, summation of fx is equal to 0. So all the the horizontal and the vertical direction, which is the NC and so first we need to identify its degrees. Since this one and this one has a perpendicular, so this one is 30 degrees. So 30 and 30, so we come up. So as you can see here, if there's an arrow that, if we draw an arrow here, it will become a right triangle. 19 minus 30 is equal to 60. So the angle here is 60 degrees. So the direction the direction that going in a vertical direction, so NC is equal to NC sine 60. So at the horizontal direction, NC cosine 60 degrees rather. 60 degrees. So TAB cos 50 and minus NC cos 60 is equal to 0. So to solve for TAB, all we have to do is isolate TAB, and since we have the value of NC, all we have to do is plug it in. So 151.71 cos 60 degrees divided by cos 15. If we calculate it in our calculator, the answer will be 78.53 Newton. And to solve for AY, all we have to do is sum all forces that goes to y direction. The summation of forces y is equal to 0, assuming that it is in the upward direction, positive upward direction. So since A has a vertical direction, so it only has one support or one direction kay roller man ang iyang support. So it is going to the upward direction, so it's positive. So AY plus TAB sine 60 and sine 15. Sorry. TAB sine 15 minus the width or the center